In this video, we're going to take a look at the technique known as factor by grouping. And that's an apt name because that's exactly what we're going to do. We're going to group these multiple terms into pairs, and we're going to factor those individual pairs using GCF factoring. So this uses GCF factoring. So it's a pretty natural extension of the technique shown in our previous video. So what do I mean by factor by grouping? Well, typically what you do is you pick a pair of terms and you group them. So in our first example here, example number 3, this will be our first pairing. And this will be our second pairing. So this is group 1 and group 2. So we're going to take a look at those separately. X cubed plus 8x squared and positive 5x plus 40. And what we're going to do now is we're going to now use GCF factoring on each group. That's supposed to say group. It doesn't look like it says group. On each group. So what is that going to look like? Well, in our first group, it looks like the only GCF is x squared. That's the largest factor that will divide into both of those terms evenly. So we'll pull out an x squared and we'll be left with the leftovers of x plus 8. And for our second group, there's no power of x in common, but we do have coefficients 5 and 40, and 5 will go into both of those evenly. Let's pull that out. In fact, we'll pull out a positive 5. It's a good idea to take the sign along with you here, and this will be x plus 8. Now, both groups have a greatest common factor. Now, if you do not see the same factors show up in both of these groups, then factor by grouping is probably not the technique you should be using. But in this case, we can see, we can see if I don't scribble it out, we can see that once we do factor by grouping, we now have another GCF. Both of these guys have x plus 8 in common. So that is our new GCF. We now have a new GCF of x plus 8. So when we factor out an x plus 8, from the first group, our leftovers are x squared. And from the second group, our leftovers are a positive 5. So this was the new GCF. And this was the leftovers. And that's factor by grouping. We factored it. Let's try it again in this next scenario. So again, we're going to pair these up. There's our first grouping. Here's our second grouping. Note the negative sign there and watch how this is dealt with. So in group number 1 here, group 1, the GCF, let's see, is 6 and 36. Both have a 6 in common. And QZ and RZ, they have a Z in common. So we'll pull out a from 6QZ plus 36RZ, we'll pull out a 6Z. And in the first term, we'll be left with a Q. And in the second term, if we pull out a 6, we'll be left with another 6. If we pull out a Z, we'll have an R. And there is our GCF factoring for group number 1. In group 2, first of all, they're both negative. So our GCF can be negative here since they're both negative. We'll pull out a negative. The largest number that divides into 4 and 24 evenly, that's going to actually be 4. They don't have a Q in common, but they do have a Y in common. So that's going to be our new GCF. So for negative 4qy minus 24ry, maybe I should make all those a different color here. Hold on a second. It's getting hard to look at that red. Blue. No. No. Purple. Okay, that's better. When we pull out that GCF of negative 4y, our leftovers in the first term of the second group is q. That's good. And when we pull out a negative 4, we get positive 6. And we're pulling out a y, so we're left with r. And now, again, we can see that we have this new GCF from group to group. A q plus 6r showed up in both of our terms. So we can factor out our new GCF of q plus 6r. So when we pull out a q plus 6r, the leftovers from the first term is 6z, and the leftovers from the second term is negative 4y. Now, we can actually go one step further. I don't know if you noticed this, but it turns out that there's still more GCF factoring we can do on this second factor, as 4 and 6 are both even. So what we're going to do is we have our q plus 6r, and we're going to factor out a 2, and this will be 3z minus 2y. And we often rearrange that with our lone coefficient out front, so maybe we would write this as 2 times q plus 6r times 3z minus 2y. That's just more GCF factoring, but the factor by grouping technique is really illustrated up in this step as we break them up into two groups and we look for a new common GCF between the groups. And that's factor by grouping.